few example problems. It says, write the equation of a circle in standard form. Don't panic when you see that instruction. If you watch the pre-lesson, you know the basic equation for the circle with center 0, 0, and you know the basic equation if the center's been shifted, okay? So, look at this. It couldn't give you an easier problem. So remember, this center's been shifted right 2 and down 1. We're going to stop right there. So to take care of that, we're going to go x minus 2 squared. There's our 2 to the right, plus 2 down would be minus 1 squared. And if the radius is 3, don't you dare put that right there. Remember, it's always equal r squared, so that would have to be 9. Some of those can be that easy. Problem number 2, getting a little more difficult. Write the equation, sketch the graph, find the domain and range. So here's your information. Start here, write the equation. Well, if the center is the origin, that just means 0, 0, which means it's going to be x squared plus y squared. No shifts, so there you go. Equals radius squared. So if this is my radius, I got to square it. Now the square root of 3 times the square root of 3 technically is the square root of 9, which is just 3. A lot of people have the trick, that just cancels with that. They're not wrong. So there's my equation. So it says sketch the graph. Okay, well, center 0, 0. Now be careful. This does not say your radius is 3. It tells us the radius is the square root of 3. You take your calculator, it's approximately 1.7. Somebody with 2 in both directions, 1.7's there, ish, and ish. Sketch. So they don't want it perfect. Domain. All right. How far left does it go? Well, it gets to 1.7. So I'm going to write it like this. Negative 1.7. How far to the right? 1.7. Well, how about the range? Well, it's also negative 1.7 bracket, up 1.7 bracket. So domain and range are the same. But remember, if you write this for the domain, it's talking about the x's. If you write it for the range, it's talking about the y's. But because it's a circle, they're the same. Now they're going to mess with you with a fraction. Don't panic. Find the equation of the circle with center. So we're like, okay, I think I'm getting the gist here. There's my adjustments for the center, equals, don't you dare put 5/2 here. If r is 5/2, you got to square it. So it's 25/4. That easy sometimes. There's more difficult ones coming. All right, a little life application problem is found on page 474, example 3. So it's talking about this park, the veterans facility. They want a spotlight right here. They want a spotlight right here. They do tell you it's on the endpoints of a diameter. So that's telling you that if I draw a line straight through, that has to be my center. Now they're asking for the equation of this fenced off area, and they're putting a statue to honor the veterans right there in the middle of the circle. Then it asks you, all right, find the equation of this, and then they're going to get into some interesting questions. So how do we find the equation? Well, we got to know the center. Now here comes those formulas from the pre-lesson. If I've got these points on the outside, and then points of my diameter, I've got to use the midpoint formula to find that. The midpoint formula is x1 plus x2 over 2, comma, y1 plus y2 over 2. Now remember, it's a midpoint, so it's going to look like a coordinate. So you're just going to say, all right, here's my first x, here's my first y, here's my second x, here's my second y. By the way, somebody else could call this x1, y1, and call this x2, y2. It's not going to mess with the formula, so don't feel panicky about that. x1 plus x2 would just be 2 plus 10 over 2, y1 plus y2 over 2. Now, Finish this off. 2 plus 10 is 12, divided by 2 is 6. 2 plus 8 is 10, divided by 2 is 5. So we know now that the center is 6, 5, which tells us we can put x minus 6 squared plus y minus 5 squared. Now we got to find the radius and square it. How are we going to do that? We got a distance formula. Remember what I said? You can go distance formula here, distance formula here, or distance formula here, but make sure to cut it in half. Well, let's take the easiest road. I'm going to use this point and this point. So I'm going to say, you know what? I'm not going to worry about that point anymore. So now this is x2, y2. I want to find this. Ooh, there's a bad teacher thing. Not bad though, I pulled it off. So the distance formula, see if I'm spelling the board here. Yes. All right. So the distance formula is x2 minus x1 squared, y2 minus y1 squared, and here we go. Got to plug and chug and remember your basic algebra skills. So here we go. x2 is 6, x1 is 2 squared plus y2 is 5 minus y1 is 2. And let's clean this thing up. 6 minus 2 is 4, 4 squared is 16, 5 minus 2 is 3, 3 squared is 9. Now a lot of students go, square root of 16 is 4, square root of 9 is 3, so they get 7. Be careful, that's wrong. This is kind of like a PEMDAS thing where you got to clean stuff up in the square root first. So I get the square root of 25, because that's what 16 and 9 is, and I get 5. Well, this is my radius. What do I do with that? Well, I put it right here, and I get 25. All right, then they try to add a little bit extra real-life application sauce by saying they're looking to put a kiosk in this fenced-off area. This circle represents a fenced-off area. So they're wondering to put the kiosk in a certain place and wondering if their plans are going to actually work. So they're wondering if they should put it at 9-1. Now my drawing's way off, but if that's 6-5, then 9 would be over here, and it's like, somewhere in here. Well, how would you know whether that even fits in the area, in this space? Well, we're going to take this point, x, y, plug it in here. So 9 minus 6 squared plus 1 minus 5 squared. And we're going to ask ourselves, does this equal 25? But there's an interesting interpretation here coming up, so be prepared. 9 minus 6 is 3. 3 squared is 9. 1 minus 5 is negative 4. Squared is 16. And if you look at that, you're like, yep, that's true. So yeah, put the kiosk right there. Here's the problem. Remember, this number is r squared, and so we're saying it's equaling r squared in a way. So if we're saying r squared equals r squared, we want this side to be less than this. Notice the equal. I get 25 equals 25. That means if they put the kiosk right there by their plans, it's going to be right on the fence. But we don't want that, okay? We want it inside. One more example to show you how you'd know that. So they're going to consider a different point. Let's try 4, 9, because 9, 1 didn't work. Put 4 in for x. Get 4 minus 6 squared. Put 9 in for y. 9 minus 5 squared. And again, we want this to be less than 25. So this is negative 2 squared is 4. 9 minus 5 is 4, squared is 16. Is that less than 25? Yes. So this would be an actual good spot to put it. Now what if they said, all right, find the area of that closed off area? Well, you'd have to use this formula. You know, oh, I need r. Well, you have r. So that would be pi times 5 squared, and it's 25 pi. Now, if you wanted to figure out what it really is, you'd multiply that by 3.14, but a lot of times they just leave it like that. And that would be square units. A little reminder of your geometry. There's your sample problems. Good luck on that homework.